As a security leader, you're not expected to configure scanners or write detection rules, but you are responsible for ensuring that application security is tested thoroughly and continuously, and that the right tools are in place to catch vulnerabilities before they're exploited. This means knowing what each tool does, where it fits in the SDLC, and how to make sure your teams are using them effectively. Each of these tools plays a different role, from analyzing code to inspecting running apps. When you know how they complement each other, you can build a layered testing strategy that covers development, deployment, and runtime. Let's break down the 5 essential categories of application security tools you need to understand and lead with. Each one plays a different role in protecting your applications, and your job is to ensure they're used together in a layered, strategic way across the development lifecycle. Start with SAST, which stands for Static Application Security Testing. These tools scan your source code, bytecode, or binaries before the application even runs. You use SAST early, during development, to catch issues like hard-coded credentials, insecure functions, or logic flaws. Your responsibility is to embed SAST into your CI/CD pipelines, align the scans with your coding standards, and set clear thresholds for what must be fixed before code progresses. SAST is your first line of defense and one of the most developer-friendly tools you can deploy. Next, you need to look at SCA, which stands for Software Composition Analysis. Today's applications rely heavily on open-source components and third-party libraries. SCA tools help you identify what components you're using, check for known vulnerabilities, CVEs, and validate license compliance. You need to ensure your teams run these scans regularly, maintain a software bill of materials, that is SBOM, and actively track outdated or risky components. When a zero-day vulnerability like Log4 Shell hits, SCA gives you the visibility to act quickly and precisely. Then comes DAST, which stands for Dynamic Application Security Testing. DAST works by testing your application in a running state, just like an attacker would. It probes for flaws such as SQL injection, cross-site scripting, XSS, and authentication issues. You want your teams running DAST in staging or pre-production environments before each release, and your role is to make sure findings are not just reported but also triaged, prioritized, and remediated before go live. Alongside testing tools, you also need WAF, which stands for Web Application Firewall Protection. A WAF sits in front of your app and inspects incoming traffic, blocking malicious payloads like injection attacks or bot-based exploits. While it won't fix the vulnerabilities in your code, it gives you a real-time defensive buffer. You're responsible for ensuring the WAF is well-tuned, monitored, and integrated into your threat detection tools like your SEM. Lastly, consider RASP, which stands for Runtime Application Self-Protection. RASP is embedded within the application itself, watching how it behaves in real time. If something abnormal happens, like an unexpected function call or injection attempt, RASP can intervene directly by blocking or alerting. It provides deep visibility and is particularly useful against zero-day attacks or runtime issues that traditional tools may miss. You need to assess whether RASP fits your application architecture, especially for high-risk or customer-facing systems. Each of these tools offers a different kind of visibility and defense. Your leadership lies in bringing them together into a coordinated program, ensuring your development and operations teams are covered at every stage, from code creation to runtime protection. When used together, they don't just secure your applications. They support faster, safer, and more confident delivery across your entire digital ecosystem. Your job isn't to choose a single tool and hope for the best. It's to build a balanced, layered application security strategy that brings together multiple forms of detection and protection. That means embedding SAST and SCA directly into the development process so vulnerabilities and third-party risks are identified early. It means using DAST during staging and pre-release testing to simulate real-world attacks before code goes live. You also need to deploy WAFs in front of public-facing apps to catch malicious traffic at the edge, and evaluate RASP for high-value or high-risk applications where runtime protection is critical. But the tools are just the beginning. Your real leadership comes from defining what good looks like. You need to set clear thresholds for acceptable risk, integrate alerts into workflows your teams actually follow, and make sure that when vulnerabilities are detected, they're triaged quickly and resolved properly. Tools don't automatically deliver outcomes. You do. Through governance, prioritization, and visibility, you turn static reports into real, measurable improvements in security. That's the difference between having a tool. So, what's your leadership takeaway? Application security isn't solved by a single tool. It's a system of overlapping protections. Your leadership is what turns a list of scanners into a well-oiled program that supports secure, fast, and confident software delivery. When you integrate these tools thoughtfully, you're not just testing code. You're strengthening every layer of your application stack.